The topic which we are going to discuss is Euclidean's shortest path problem using network simulator. The problem statement is the Euclidean's shortest path problem is a problem in computational geometry. Given a set of polyhedral obstacles in a Euclidean space and 2 points, find the shortest path between the points that does not intersect any of the obstacles in 2 dimensions. So, this is a visibility graph of polygon. Order of n log n algorithm does not find the optimal shortest path. To find the optimal path, we need a tool called the visibility graph. So, the visibility graph of a polygon is a graph whose nodes corresponds to the vertices of the polygon and whose edges corresponds to the edges of the polygon formed by joining the vertices that can see each other. So, the figure below shows the visibility graph of the polygon. Visibility graph of a set of obstacles is a bit more complicated. It is a graph of nodes from the same and from different obstacles that can see each other. The edges formed must be external to the obstacles. So the figure below shows the visibility graph of a set of obstacles. Visibility graphs gives the shortest path, which is known as lemma. Any shortest path between P start and P goal among a set S of disjoint polygon obstacles is a polygonal path whose inner vertices are vertices of S. Proof by contradiction. Suppose there is a shortest path B that is not polygon as shown in the diagram above. We take point P on B. Since P is in the interior of the free space, there is a disk of positive radius centered at P that is completely contained in the free space. The path of B inside the disk, which is not a straight line segment, can be shortened by replacing it with a straight line connecting the 2 points where B enters the disk and leaves the disk. This contradicts the assumption that B is the shortest path, since any shortest path must be locally shortest. That is, any subsections of a shortest path must itself be the shortest path of that section. By this lemma, the segment on a shortest path have visibility edges except for the first and last segment. To make them visibility edges well, we add the start and goal position as vertices to S. With this visibility graph as our roadmap, we can now determine the shortest path by single source shortest path algorithm. We will return to an example of such an algorithm, which is known as Dijkstra algorithm, after presenting algorithm for computing visibility graphs. So this is the algorithm for computing visibility graph of obstacles. So the input and output. The input is set of points defining the obstacles and the output is set of points which corresponds to the visibility edges of the obstacles. So there are several algorithms exist with different time complexities. Order of n cube naive algorithm, order of n square log n binary search tree algorithm, order of n square algorithm using arrangements, and order of n log n plus e algorithm where e is the number of edges in the graph. In the worst case, e is equal to order of n square for your complete graph, but it is uncommon to have a complete graph. This algorithm is output sensitive. Simulation is an important tool for the validation and performance evaluation of the system. Results can be obtained using internet model. 4 approaches for internet delay model are analytical function, the king method, the topology generators, and Euclidean embedding. Euclidean embedding seems to be an optimal trade-off between computational cost and memory overhead.